Hello, Math 80 students. I would like to do a quick overview of using your TI-89 calculator to find the value of factorials and combinations. So it's a great shortcut, as we will see with this demonstration. So I'd like to take a moment and discuss what a factorial is. A factorial, which is notated with an exclamation point, means, for example, if I was doing 7 factorial, that I take that value and I go and multiply by 1 less and 1 less and 1 less until I am down to 1. And we can do this in our calculator by just doing that. Let me get the light a little bit better here. So I could take 7 times 6 times 5 times 4 times 3 times 2 times 1 and find the value of 7 factorial. $5,040. Now, imagine if you had to figure out what something much larger was, like 26 factorial. Or even larger. You might not want to sit there and type in 1 less, 1 less, 1 less, 1 less until you get down to 1. So it's really nice to have a function on your calculator that will do it all for you at the press of a button or two. So 7 factorial, or any factorial, you're going to need to type in the number that you want to find the factorial of. So 7 in this case. You're going to go into math, which requires you to hit second 5. You're going to scroll down to probability, because this idea of factorials and combinations is related to all sorts of probability topics, binomial theorem and things like that. So if you're in the probability, you hit the right arrow and you select option 1, which is the factorial. So again, it's second button and 5 to get you to math. And then you will, so let me model that again. Factorial, enter, and enter. Okay, so you will do your number. So in this case, 7. Second, 5. Then you will go down to the probability submenu and hit the right arrow to open up the next submenu. And option 1 is factorial. So you'll hit enter to select it. And then you'll hit enter again to evaluate. And you can see it gives us the same value as we had before. Okay. So let's try a few more. What if I wanted to figure out what 12 factorial would be? 12, go into the math by doing second 5, go to probability, go over to option 1 factorial, hit enter, and enter again. So you can see it's getting very large very quickly. Now let's try like 26 factorial. And now you can see it is so large that I even have to scroll over to get it all. The other option, if you wanted to write this in scientific notation, is to hit the diamond and enter. And it will I don't have that setting on. It can convert it to scientific notation if you are in the mode doing scientific notation. I have it on float right now. Any case, let me escape that window. You can imagine that it might get too big, in fact, for even your calculator to handle with the scroll. Let's try something like 500 factorial. And it just gives us back 500 factorial. It's just too big to really deal with. If I tried 1000 factorial, you could imagine even bigger. So I could hit the diamond enter, and it'll actually say infinity because it is so large it can't even handle it, so it'll actually go to infinity. The value isn't actually infinity, it's just that your calculator cannot handle it. Too big. So why are we talking about factorials? Well, they're going to be used for combinations. Now, combinations, we have this notation, nCr. Sometimes it's nCk, but nCr stands for how many items you're choosing from and how many you're choosing. So if you go to a pizza place and they have, 6 toppings available and you are going to pick 2, how many different kinds of pizzas could you make? So that's combinations. How many combinations of pizza could you make? So in that case, what I was just describing is 10C2. Your R can go from 0, choosing nothing, all the way up to that n value, in this case 10. And you will see that when you do binomial theorem. So what is the value of 10C2? There are a couple ways to determine that. One, you could literally draw out your having 10, I was going to do 6 toppings. You could draw out pizzas where you have 2 toppings out of 6 options and see how many different combinations you'd get. Alternatively, you can use the nCr formula. The nCr formula is n factorial divided by r factorial times n minus r factorial. So you would do 6 factorial divided by 2 factorial times 6 minus 2 factorial. You would simplify that, and you can type it into the calculator like this. And the benefit of that is that what if this number was so big that your calculator couldn't handle it? So sometimes it's good. It can handle it when it's in combination with, dividing out some of it. So to do that, just so we can practice, 6, go to math, so second 5, go down to probability, probability, option 1, then divide by the quantity, or both of these need to be in the denominator, so 2 factorial. You can write 2 factorial, it's just 2 because it's 2 times 1. Probability NC, factorial, and then times 4 factorial, end your parentheses and enter, and you will get 15. Another way to figure out the value of an nCr is using Pascal's triangle, where each row begins with 1, and then it is the sum of the terms directly above it. So it keeps going outwards by doing 1. 1, 4, 6, 4, 1. And this is for a power of 1 for when we do binomial theorem, power of 2, power of 3, power of 4, power of 5, sorry, power of 0, power of 1, power of 2, power of 3, power of 4, power of 5, power of 6. And what this corresponds to would be 6C0, 6C1, 6C2. So you can see that 15 matches up. So you can also use Pascal's triangle, but you might not want to go if you have to go out too far for your n, for what will be the exponent. But it does work. So how do we do this even quicker with our calculator? So with the TI-89, you are going to have to say you want to use that feature, that function of the calculator. So I'm going to clear just so I don't have that there. We're going to go into that math window. So the second 5 to get to math, we're going to go to probability, and instead of selecting the factorial, we're going to select the nCr open parenthesis. And now you're going to put your n value, which is 6, comma, your r value, which is 2, and then hit enter. And you'll get 15. So there it is. You put in your nCr function, so you're going to do second 5 to get math. Then you're going to scroll to probability. Then you're going to pick from that option 3. Hit enter to select it. Type in your R value, comma, sorry, your N value, comma, your R value, and parentheses, and enter. And you will get 15. So I hope that helps when it comes to calculating specific values of nCr. Good luck.